question here from Mark. He's saying in the chat, why did you say graphene is a shape, perhaps hexagon, but keep thinking of graphene is a material like sp3 and sp4, superconductors or superconductors? Could be missing your point of five-sided shape?
And what we call sp3 or sp4 is different explanation of the same thing.
Então, o que é chamado sp3 e sp4 é diferentes explicações da mesma coisa.
Superconductivity is when all the elements align and we don't have superconductivity. Superconductivity in the science of nanotechnology is the being able to transfer energy on the magnetic fields and not on the matter fields. In the world of science, in the matter state, materials are connected like this. We call them a molecule. There could be any sizes, it could be a mixture of molecules. And they sit like this, connected to each other. This is what we call matter state. If I number this 1, 2, 3, 4, and 5. In the nanotechnology of today, we did heat transfers, we do through caustic or by fire, we still have these layers. But the top layer goes like this when you heat it. Now this is your number 1, this is your number 2, 3, 4, and 5, and 6. So now this is a molecular structure. This is a below molecular. Here you're a nano. Where the distance separation here, they still have magnetic fields, but the magnetic fields here are connected to each other. We call them, we see them as molecules. And it could be many layers of this underneath. Now what you have a magnetic field of the matter, which is, because of connection to each other, is very weak, and magnetic field of nanomaterial, which is a space gap. And the same from here. And the same with the other points. Now you have created a nano layer. Here, the bound is very close. If we take many of these, when you see a nano layer black, it is over 30, 40, 50,000 layers over each other. In this order, now you see a magnetic field gap. Each atom has separation magnetically by its field forces. They are not connected like here, compact together, locked in. Now there is space gap. So now you can, here, if you wanted to put something in this layer, you had to drill your way through to separate. You hammer your nail through it to separate, to find a space gap between the molecules. Here, the story is different. You can send anything electronic or electrical or any frequency through here. There is no resistance. It's a magnetic field resistance. And so here you spend time when even you put electric current, the electrons of these things have to vibrate to go, and that vibration creates friction and heat and delay in energy to transfer from A to B. In a nano layers gap, you don't have that, because this itself is made of electromagnetic fields or a magnetic fields and interacts with another magnetic fields. It does not interact with matter state. And then what happens? You fly through. This is what we call superconductivity. Here you're conductive, you go by going through. Here you go on a bed of electromagnetic fields, not on a matter magnetic fields. You go on a plasma magnetic fields. Here you have an electromagnetic field, you add current to it, you can create a small magnetic fields above it. You see it in the trains and anything else which create levitation. But that is a matter state, very short term, and is dependent on energy. And you lose a lot of energy. In a superconductivity, you fly along between what we call nano layers. No contact with the atoms. Flying over, it's like you're flying a feather in the air. This is what is called as superconductivity. Now, in a Keshe Foundation technology, we are far ahead of this. We don't describe it, we don't explain it, because we have developed technologies which can lead to a lot of other next steps of the science and technology. We use this now in what we call the enhancement units. We use them in the new communication units and all sorts. But the beauty of it is, if you look, this flies along because these are lined. This is a line of an atom. This is a line of another atom. This is a line of another atom. So you have different channels to pass your information without any losses. Energy at A is energy at A on the other side. You don't have an A and B as you saw in a matter state. You don't lose anything because you don't have to interact with anything. You fly over magnetic field. Losses are very little. But when we go into a higher level, which is not known by man, we still have losses, but this in the new technology we have overcome. But when you put current or information through here A, you get A back. But with nanomaterial, for it to be positioned, they are not in line with each other. They are offset line. You can see it. So you have an energy trap gap, which this energy trap gap, if any radiation enters it from outside, gets trapped in this or in another energy trap gap because they're different below it, and none of it can return back and the material looks black. But if you look at the superconductivity, what you see here, you see the same light as here. You don't lose any energy. So nanomaterials, the way we produce it, are super resistance here, superconductor on this side. Because here, this is the reason when, if you listen when we tell you to produce nanomaterials, we tell you when you take the caustic or the metal out of the caustic to give it an electric connection to realign all these cells. That in realigning, your space gap stays constant and you create perfect gaps. And in these gaps, if we capture any energy because of the matter state energy conversion, it becomes graphene. If we capture a carbon between the copper and can hold it, it becomes a gas of it because it's not physical material, it's a gas material confirmed, held, becomes ordered. This is what you call graphene. Where here you have the nanomaterials. Here you have a graphene because it creates the gap to be able to trap the energy of the carbon. This is what a conductor and a superconductor is. We don't have a superconductor. Once we are, when you speak about, if you want to say superconductor, is when we transfer energy through not even atomic structure. We transfer energy through another different dimension, which Keshe Foundation is working on now. If you want to call it the superconductor. The superconductivity is what you see in the green line. If you go into what you call superconductivity, this is the technology which we will use on the 6th of June for transportation to Moon, which is a different technology than what we have taught up to now. Then transportation and transmutation becomes totally different criteria. In a way, we transmute on what we call the cosmic level. And then that depends on your government, how negotiate for what we call peace, that this technology will be released. Then you travel from here to Moon within minutes.